Now, first of all, let's see what does it mean by current, electric currents. When we talk about current, here is electric currents. By definitions, current is the rate of flows of electric charge. Rate of flows of electric charge in conductors. Okay, cancel this flow. Okay, we don't need to have two flow here. Cancel the word flow. Now, if you still remember, in physics or in chemistry, when we talk about rate, what does it mean? What does it mean? If we talk about rate, it means what? How fast? How fast the change occurs, right? How fast the change occurs, So rate of flows of electric charge, sorry, this one, this not the charge, we should cancel the flow, the word flow, okay? Current is the rate of flows of the electric charge in conductor. So rate of flows of electric charge means how fast the charge flow. How fast the charge flow. So current is a measure of how fast the charge flow. So this is very different from the words current that we use in daily life. In daily life, okay, if there is no electricity, then we say no current. No current. So that current means there's flows of electric charge, but it's not the rate of flows of electric charge. In physics, when we talk about current, is how fast the electric charge flow. The equations. In equations, we write current equals to the amount of charge flow divided by time, or the formula I equal to Q over T. So this is the equations or the formula for current. Amount of charge divided by time taken, or I equal to Q over T. Q is the amount of charge and T is the time taken. I is current. The next thing that you need to know is the directions of current. Okay, this is important. This is important, the directions of current. Okay. Conventionally, the directions of the electric current is taken to be the flows of positive charge. Flows of positive charge. What does this mean? The electrons flows in the opposite directions to that of the conventional current. Now, for examples, let's say there is ions. There's ions, two types of ions, positive ions and the negative ion. The big one, the blue one, is the positive ions, and the small one is the negative ions. And these two types of ions, or these ions, are put into an electric field. And if you still remember, last week we learned that if we have charge in electric field, there will be the force exerted on the charge to make the charge move. So any charge in electric field, they will have a force exerted on it to make it move. Now, in this case, the positive charge moves to the right and the negative charge moves to the left. Always remember, the negative charge always move in the opposite directions of the positive charge. They always move in the opposite directions. If the positive charge move to the right, the negative charge will move to the left. And if the positive charge move up, the negative charge will move down. And the positive charge move to the right most probably is because there is a positive plate, electric plate. The negative plate here. So, or there is a positive plate here. Okay. So the negative charge will move to the positive plate, and the positive charge will move to the negative plate. Now, if this is the case, then we say the current move from left to right. The current move from left to right. Why? Because the directions of the current is the same as the directions of the positive charge. The directions of the current is the same as the directions of the positive charge. And the directions of the negative charge is always in the opposite directions of the current. And electrons carry negative charge, right? So the electrons always move in the opposite directions of the current. If the current is to the right, then the electrons move to the left. If the currents move up, the electrons move down. So currents always in the same directions of the positive charge, but opposite directions of the electrons. or negative charge. That is what you need to know about the directions of current. Then how about directions of current in a circuit? So in a circuit, current flow from the positive terminal to the negative terminal. Because in a circuit, you can't see the flow of the charge, right? You can only see the battery. Yeah? So they will give you, they give you the battery, something like that. Okay? And then they ask you to label the directions of the currents or label the flows of the currents. Okay, so how to label the flows of the current? Now, first you need to know for the cell, the longer one is positive and the shorter one is negative. And current, it moves from the positive terminal. Positive terminal is the positive of the cell, positive terminal of the cell. So it moves from the positive terminal. So this is current. Current moves from the positive terminal to the negative terminal. Okay, so current from the positive to the negative. This is outside the cell. External circuit outside the cell. Outside the cell, it moves from positive to negative. But inside the cell, you see the current move from negative to positive. Inside the cell, it moves from negative to positive. Outside the cell, it moves from positive to negative. Inside the cell, negative to positive. That is the flow of the currents. Usually in physics, they will ask you about the directions of the current. But in chemistry, sometimes they will ask you to label the directions of the flows of the electrons. Usually is in electrochemistry. So in electrochemistry, they will ask you to label the directions of the flows of the electron. Okay, if they ask you to label the flows of the electron, then the electrons move from the negative terminal to the positive terminal. So current from positive terminal to the negative terminal, and electrons from negative terminal to the positive terminal. So that's what you need to know about the directions of current in circuit. Okay, unit of current. The SI units of current is ampere, okay, denoted by the symbol A. But what is ampere? What is ampere? Just now, we learned that current is given by the formula I equal to Q over T, right? I is current, Q is amount of charge, right? And T is time taken. So current is a measure of how much the charge flow in 1 unit of time. 1 unit of time, okay? So let's say there is a wire. Okay, so this is a wire. And inside this wire, there's a lot of electrons. There's a lot of electron inside. Okay. And this electron, this electron move from left to right. Yeah, left to right. If we take this cross-sectional area and then we stand here and we count. Yep. How much charge pass through this cross-sectional area in 1 second? How much charge pass through this cross-sectional in 1 second? And if we found that there is 1 coulomb of charge, 1 coulomb of charge flow in 1 second, 1 coulomb of charge flow through this in 1 second, then we call this as 1 ampere. 1 ampere. So 1 ampere is means 1 coulomb per second. Means there's 1 coulomb of charge flow through this point or this cross-sectional area in 1 second. Now, if the charge flow faster, let's say 2 coulomb flow in 1 second. 2 coulomb flow in 1 second, then we say the current is 2 ampere. If even faster, 5 coulomb in 1 second, then we say it's 5 ampere. Because current is how fast the charge flow, right? The more the charge flow through 1 point, the faster it flow, right? The higher the current. So that's the meanings of 1 ampere. Okay, 1 ampere. That's 1 coulomb of charge flow in 1 second.